In this tutorial we're going to be looking at the modulus function. Now by definition our modulus function, which is written with two straight lines like that, this would be read as the modulus of x, by definition is equal to the square root of x squared. Okay? And basically what it means is whatever you put in here for x always is positive. Or it becomes positive, I should say. Okay, so for example, the modulus of -3 equals positive 3. Okay, if we were looking at something like the modulus of 4x being equal to 16, okay, well then we could obviously see that our x value has to be 4, but it doesn't just have to be positive 4, it can also be -4, because the modulus signs will make it positive. Okay, modulus signs can also be used to represent domains as well. So we had a number line here, we had 0, 1, 2, 3, and -1, -2, -3. Well, the modulus of x being less than 2, okay, means that we're actually talking about the region from -2 to +2. Okay, so we can actually use modulus signs for domains. Now we don't do that very often, but we can do it. Okay, if we start talking about graphing modulus functions, which we do in a bit more detail later on, basically what it means is if you've got some function, okay, and it could be something like this. Okay, so it could be x squared take 2. Okay, well, if we look at the function where we have y equals the modulus of x squared take 2, well, we know that it always has to be positive. Okay, we know that the modulus signs make everything positive, so what happens is this part that's underneath becomes positive, okay, and gets reflected in the x-axis. But these parts here remain the same. Okay, and this -2 becomes +2. Okay, so the purple would be the graph of that. Now, to actually define that, okay, well, we need to break it into a piecewise function, okay, and define these parts as well as these parts together. Okay, so we should all be pretty comfortable with the fact that our x-intercepts are -√2 and +√2. So if we were to define this function as a piecewise function, then it would be y equals, I'll do our big bracket, okay, well it's our positive version, x squared take 2, when x is less than or equal to -√2, so that's taking into account this section up there, or we're greater than or equal to +√2. So that's taking into account this part. Now our middle part though is actually -x squared take 2. Okay, and that's for our range of -√2 is less than x, which is less than +√2. Okay, so our big ideas, okay, are that modulus of x, okay, means, okay, that whatever's inside here is positive. Okay, we can use it for domains, okay, and in terms of graphing, anything that's below the x-axis gets reflected in the x-axis. Okay, so hopefully that helps you with our introduction into modulus functions. You can have a look at a couple of the other worked examples in the textbook. We've looked at a couple already just in there, okay, but there's probably a few more that you might want to have a look at.